So today we will be learning about trigonometric functions. Some reviews of triangles that we need to know before we get started are all of the angles of a right triangle should add up to 180. The angle of a right triangle, which is known as the right angle, is 90 degrees. And one thing that should be a review is the Pythagorean theorem, which is a squared plus b squared equals c squared, also known as x squared plus y squared equals r squared. Sides a and b should add up to c. If not, then it is not a right triangle. Some new trig things that we need to know we will not be using degrees for the triangle's angles. We will actually be using radians, also known as theta. And a circle, it's not known as 360 degrees. It is going to be 2 pi radians. And half a circle, which is 180 degrees, is going to be known as pi radians. Well, what is pi? Well, the definition of pi is actually a number. It is approximately 3.142, but we will be using it as 3.14. The circumference of any circle is divided by its diameter, which is the definition of. Well, what is a trigonometric function? Well, the definition is one of the many functions that relate one non-right angle of a right triangle to the ratio of the lengths of any two sides of the triangle. Each triangle is started from the positive x-axis and works counterclockwise. Instead of using degrees, like I said, we will be using radians. So for 30, 45, 60, and 90, it's all going to be pi over 6, pi over 4, pi over 3, and pi over 2. So let's start learning trig. So for theta equals pi over 6 radians, also known as 30 degrees, the x-coordinate is going to be rad 3, the y-coordinate is going to be 1, and the radius is going to be equal to 2. As shown from the Pythagorean theorem, it does make sense and is a right triangle because rad 3 squared plus 1 squared equals 2 squared, which is also 3 plus 1 equals 4. pi over 4 radians, also known as 45 degrees, is a pretty simple triangle that will be very familiar and easy to recognize. The x-coordinate is 1, same with the y-coordinate, which is also 1, and the radius is rad 2. Shown from the Pythagorean theorem, 1 squared plus 1 squared equals rad 2 squared, or 1 plus 1. For pi over 3 radians, or 60 degrees, the x-coordinate is shown as 1, the y-coordinate is shown as rad 3, and the radius is shown as 2. From the Pythagorean theorem, 1 squared plus rad 3 squared equals 2 squared, or 1 plus 3 equals rad 4. One easy way to show or to remember pi over 3 from pi over 6, the shorter side is always going to be 1. So for pi over 6, since y is the shorter side, that is going to be the 1. But for pi over 3, since the shorter side is the x-axis, that is 1. They are very similar triangles, but it is easy to tell the difference after looking at it. So just getting to know the function, when doing a trigonometric function, there are 3 components that are brought up from triangles. So we will be learning 3 functions known as sine, cosine, and tangent. For sine of theta, it is equal to y over r, or also the opposite over the hypotenuse. For cosine, it is known as x over r, or the adjacent over the hypotenuse. And for tangent, it is y over x, or the opposite over adjacent. One easy memory trick to remember this is SOHCAHTOA. So for sine, it is opposite over adjacent, or over hypotenuse. For cosine, it is adjacent over hypotenuse. And for tan, it is opposite over adjacent. Some examples. So let's get into it. Let's find out why pi over 6 and all these functions do equal each other. So for sine of pi over 6, it is equal to 1/2, because remember, it is y over r, or the opposite over the hypotenuse, which is equal to 1/2. For cosine, it is x over r, or the adjacent over hypotenuse, which is rad 3 over 2. And for tangent, it is 1 over rad 3 because it is always the y over the x. One easy way to solve this, you are going to be taking the top number from sine and putting it on the top number for tan, and you're going to be taking the top number from cosine and putting it as the denominator for tangent. This can be used for any of the triangles. For pi over 4, let's look through as to why these are what they are. For sine, it comes out to 1 over rad 2, but once you simplify it, which will need to be done because radians should not be radicals should not be in the denominator, so it comes out to rad 2 over 2. And for cosine, it comes out to the same answer because it is also 1 over rad 2, which is rad 2 over 2. And the tangent is shown as 1.